Alright, and welcome to roughly sketching squares and square roots. Now, when we talk about a square, well, we're really talking about a quadratic function, and if you will recall, it is our U-shaped graph. So let's just talk about something very easy, x squared. X squared has its vertex at the origin, and it's just a U-shaped graph that opens up. You know this, alright? What about the square root of x? Well, as a function, it has its vertex at the origin, and it's actually kind of like it's the top half of a quadratic, just kind of going to the right. Today I'm using my bad stylus, so yeah, y'all can see it's just very kind of hard to draw it, but it's essentially taking this left half of our original quadratic, and it's rotating it 90 degrees to the right. Okay, because remember, these things are inverses of each other. Okay, so let me go ahead and show you all something else. Okay, so we see what x squared looks like. We see what the square root of x looks like. Well, what if we make it negative? What happens? Well, this negative will essentially take this, and it'll always flip it over the x-axis. So instead of opening up, well, now we know it opens down. Okay, the same is true for the negative square root of x. Instead of opening up, well, now it opens down. Once again, yeah, guys, I don't really know why this stylus writes so bad, but it'll look something like that. Okay, now we're going to talk about shifts. Okay, so for example 1, we have f of x is equal to x squared, and g of x is equal to x minus 3 squared plus 4. How does this shift? What does it look like? Well, I draw my terrible, very terrible y-axis. There's my x-axis. And I always want to start with my parent function here is x squared. Okay, so the question then becomes, if I wanted to do g of x in white, what would that look like? Well, remember, our rule is that we always take our grouping and we always set that equal to 0 to solve for the x value of our vertex. So I'd say, okay, well, I'm going to add 3 to both sides, add 3, now I have x is equal to 3. We always take our constant on the outside as is, so we say y is equal to 4, and so our vertex must be at 3, 4. So I go to the right 1, 2, 3, up 1, 2, 3, 4, and I put my point. And also, notice that here our a term is positive, so this opens up. Okay, but this is what I really want you to get at. I want you to talk about the shift, or I want you to talk about the change. We'll say this. We would say that g of x shifted 3 units right and 4 units up. And if you can describe that shift, that illustrates to me that you understand how this graph changed. Alright, let's try another one. Okay, for example 2, it says graph h of x, which is equal to the square root of x. So remember, that is in fact our parent function. Remember, our parent function starts at the origin, and since it's a square root, it'll be kind of the left side of a quadratic rotated 90 degrees to the right. Now notice here there's two things. We always want to start with finding our vertex, and I see that inside my grouping, inside there, I have x minus 2. So remember, whatever's inside the grouping, we always set equal to 0, and I will add 2 to both sides, and x is equal to 2, comma. But notice there's nothing on the right-hand side. That's like saying plus 0. So I know that the y value of my vertex will be 0. And so I know that my vertex is at 2, 0. So I'll go to the right 2, and I will not shift up or down at all, because that's 0. And lastly, I always look to see if my a value is positive or negative. In this case, it's negative, so my graph will shift down, will reflect down over the x-axis. So how would I write this transformation? I would say this. It shifts right 2 units and is reflected down. Now I could say reflected over the x-axis, but I think this is absolutely fine. Alright, let's try a more complex example. Okay, so here we have f of x is equal to x squared. Okay. So now we're looking at a quadratic function again. We got our nice little U shape here. And here I notice that, you know what, I have a negative in front of the x squared, and I have a plus 7, which is on the outside of everything. It's my constant. It's not inside my grouping. So what does this mean? Well, because this is simply x squared, I know that the x value of my vertex is at 0, and I know that the y value of my vertex is simply that constant, positive 7. So my vertex is at 0, 7. So I can go up 1, 2, 3, 4, 5, 6, 7. But I also notice that my a value is negative. That means that my quadratic will open down. Alright? Easy, easy. Alright, let's go ahead and look at our final example, the most complex yet. Okay, so here we're going to be looking at square root functions, clearly. And I know that my parent function of the square root goes to the origin, like that. However, let's take a look at g of x. I see here that inside my grouping, there's actually an x plus 4. I set that equal to 0. When I solve for x and subtract 4 from both sides, I have x is equal to negative 4, comma. I know that my constant on the outside is a negative 1, and my vertex is a negative 4, comma, negative 1. Okay, and I also see that there is a negative there. So I can go like this. 1, 2, 3, 4 to the left, down 1, and I know that that negative is going to reflect my graph down. Okay, and guys, I forgot to write out my description in the last one, but let's just go ahead right here. We would say this. We would say that the graph, or we could say g of x, shifts 4 units down, 1 unit left, and reflects down. And guys, so long as you know these simple basic rules, you can go ahead and graph any square or square root function just very simply. Alright guys, I hope this helps, and I'll catch y'all in our next video.